Hello everyone, my name is Julie Mayri Botazo and I am assigned to discuss the Chapter 3 Lesson 5.1 which is the Huntington-Hill apportionment method. Edward Vermeil Huntington was the founder of the Huntington-Hill apportionment method. He was the mathematician associated with Harvard University, known for his work in asymmetric geometry. He learned of the apportionment ideas of Joseph A. Hill. Huntington-Hill method. This method is similar to both Jefferson and Webster methods. The Huntington-Hill, Webster, and Jefferson methods are all called divisor methods because of the way in which a critical divisor is used to determine the apportionment. Like the other divisor methods, a Huntington-Hill method begins by determining a standard divisor and then calculating a quota for each state. In Webster's method, we round in the conventional way, so the cutoff for the Webster's method is zero point 0.5, halfway between the modified lower quota and modified upper quota. In the Huntington-Hill method, the cutoff is not zero point 0.5, but rather it is found by h is equal to square root of n multiplied by n. So here is the example number 1. Suppose this country has states A, B, and C, with population as given in the table below. Suppose the house size is 75 seats. As you can see in the table, the total number of the population is 1517. In order to get the quota, we need to we need to calculate first the standard divisor, which is the formula is S is equal to PH over H. The P is the population and the H is the number of house size. So 15117 divided by 75, the answer is 20.2267. That is our standard divisor. Before we will going to calculate the quota, we will going to define what is quota is. The quota rule states that the only two allocations that a party can receive should be either the lower or upper quota. As you can see on the table, to obtain the quota, we will use the formula of Q is equal to population over the standard divisor. So first, the state A, we have a population of 453 and our standard divisor is 20.2267. So the quota is 22.3962. In state B, we have a population of 367 divided by 20.2267. In state C, we have a population of 697 divided by the standard divisor of 20.2267, and the quota is 34.4595. So here, after the quota, we will going to obtain the lower quota. To obtain the lower quota, we will just going to remove the decimal point. So the lower quota of state A is 22. The lower quota of state B is 18. The lower quota of state C is 34. Next, we will going to calculate the geometric mean. As you can see, the formula of geometric mean is Q is equal to the square root of lower quota multiplied by the upper quota. So lower quota is 22 and our upper quota would be 23. So 23 multiplied by 22 multiplied by 23 is equal to 22.4994. In state B, our lower quota is 18, and multiplied to 19, the geometric mean would be 18.4932. In state C, our lower quota is 34, and our upper quota would be 35. So the answer would be 34.4964. So in initial allocation, there's a rule that there's a rule before we will going to obtain what is the initial allocation. So to get the initial allocation, we will going to compare the quota and the geometric mean. So first rule is if the quota is smaller or below the geometric mean, we will going to round down. And if the quota is larger or above geometric mean, we will going to round up. So in state A, we have quota of 22.3962 and the geometric mean is 22.4994. So the quota is smaller than the geometric mean, so we will going to round down. The way around it is just to copy the 22 of it. So in state B, we have still smaller quota than the geometric mean. So still we will going to round down. In state C, we have still a smaller quota than the geometric mean, so it's still going to round down. So the initial allocation, if we were going to add or the summation of the initial allocation is 74. They are not balanced with the quota. So in order to be balanced, we will going to use the modified divisor. First, we will going to define the what is the modified divisor. Modified divisor as opposed to quota method. Divisor methods work with divisors other than the standard divisors. So here it is going to modify divisors work. So modify divisors, as you can see in the table, the quota has been changed because as you can see the formula of the modified divisor it is MD is equal to population over N minus 1. So our population is 1517 and our N is 75 minus 1. So 1517 over 74. So our modified divisor would be 20.5. So 20.5 we were going to divide it with the number of population in each state. So 453 divided by 20.5 is equal to 22.481. In state B, 367 divided by 18.213, the answer would be 18.213. In state C, if we were going to divide the 697 into 20.5, the answer would be 34.590. So, in geometric mean, there's nothing has been changed. So, as of now, we will going to compare the two. As you can see, the quota is still small than the geometric mean, so we will going to round down it. In state B, the quota is still small than the geometric mean, so we will going to round down it. In state C, the quota is larger than the geometric mean, so we will going to round up it. It becomes 34. So now the initial allocation, the summation of initial allocation is now 75. They are now balanced with the quota. The next example. Example number 2. A college offers tutoring in math, English, chemistry, and biology. The number of students enrolled in each subject is listed on the table. The college can only afford to hire 22 tutors. Using the Huntington-Hill method, determine the apportionment of tutors. Example number 2. As you can see in the table, we have subjects of math, English, chemistry, biology, and the enrollment is 380, 240, 105, 55, 780. The total of 780. So our standard divisor is 35.4545. So as what I have did the previous slide, the number of enrollment, we were going to divide it to the standard divisor. So 380 divided by 35.4545, the quota will be 10.718, and the remaining subjects will follow. So the initial allocation is 23. They are not balanced, so we will going to apply again the modified divisor. Here is the modified calculation. So the quota has changed. Our modified divisor is 37. So the quota has changed into 10.270 in math subject, 6.486 in English subject, 2.837 in chemistry subject, 1.486 in biology subject, and now the initial allocation is 10, 7, 3, 2. And now they are now balanced. Another example. We, in this example, we are not going to apply the modified divisor. As you can see, we have a 41 seats with a population of 162, 310, 538, 479, 197,145, 897,934. So our quota is 7.411, 24.587, 9.0017, and our lower quota would be 7.2989. Our geometric mean would be 7.48, 24.49, 9.48, and our initial allocation is 7, 25, 9. And the number of seats are 41. They are balanced. So example number 4. Consider a small county within 5 states. Two of which are much larger than the others. We need to apportion 70 representatives. So our standard divisor is 8,714.28. If we were going to divide it in each population, the quota would be result in state A 34,483, 23.950, 5.737, 4.360, 2.467. In initial allocation, we have 34, 23, 6, 4, 3, and a total of 70. They are balanced, so we don't need to apply the modified divisor. So example number 5. This will be the last example. Using the Huntington-Hill method to get the apportionment with 145 seats. So as you can see, there's nothing different of the example number 5 from the previous example. So we have states A, B, C, and our population is 125,000, 50,000, 75,000, with a total of 250,000. We have here a standard divisor of 1724.14. If we were going to calculate it into the division, the quota will be 72.499, 28.99, 43.499, and the lower quota will be 72, 28, 43, and the geometric mean will be 72.498, 22, 28.495, 43.497. The initial allocation will be 73, 29, and 44. Since the summation of initial allocation is not equal to the number of states, which is 145, we have to apply the modified divisor. So here's the modified divisor. Our modified divisor is 1724.25. The quota has been changed. Into state A, it becomes 72.495. In state B, it becomes 28.998. In state C, it becomes 43.497. So, the geometric mean is 72.498, 43.495, 43.497. So the initial allocation is 72, 29, 44, with the summation of 145. Now they are balanced and equal. The apportionment with 145 is now balanced. And that would be all. Thank you.